Hello again. This is the lecture for Chapter 3. Personally, Chapter 3 is my favorite. This really lays the groundwork for how we can understand science. So I'm excited to talk about it. The chapter is called Three Claims, Four Validities. It's essentially ways that we can understand research in a very systematic, appropriate way. Not all research is created equal, and not all claims are created equal. This chapter is all about that. So first, we're going to talk about variables and why they're important. We're going to talk about the three claims, and then we're going to interrogate the three claims using the four big validities. And then the last part is going to be about prioritizing validities. Each of these will help you understand when you're going through your literature search and getting your literature review ready, what things are most important and how to judge how solid the research is. So a variable is something that varies. It's a good name for it. It's something that can change from one person to another versus a constant where that is the same for either everybody in the population or everyone in just your small sample. There are lots of examples. One example would be your grade. A grade is variable. It's different for each person. Now there's differences between what the book refers to as a measured variable and a manipulated variable. A measured variable is one that you measure. You didn't create it or change it. It's just what ended up happening. A manipulated variable is one that you actually change. So in an experiment, this would be one that you put them into one of the groups, for example, a treatment group compared to a control group. That would be a manipulated variable, whether they were in the treatment or control. So when it comes to conceptual variable to operational variable, the concept can be sometimes easier to work with initially in your head than the operational one. For example, if we're talking about depression, depression is a really complicated thing, but we understand it at a conceptual level. We understand the symptoms, what it does to people, how it's experienced. But in order to actually do research with it, we have to operationalize it. We have to say, how are we going to measure this? What will actually tell us if they have depression or not? And this is usually one of the most challenging parts if you're in a new area. If you're working in an area where work has been done, usually there are good operational definitions available that you can work from. Regardless, it's really important to maintain in your head what the difference is between those two. So conceptual is just the idea behind it, what is it? And then operational is actually how we define it. So some examples of that, the variable name could be car ownership. The concept is, do you own a car? When we actually operationalize it, one way we could do that is we could ask people to circle, I own a car or I do not own a car. This one is a fairly straightforward one. You can just ask them, do you own a car? This one, you just have two levels. You either own it or not. And this is just measured. You're not assigning them whether they own a car or not. Another one, expressing gratitude to romantic partner. This, you can see, is a little bit more complicated than just saying, do you own a car? So we understand what it is at the conceptual level, but when we operationalize it, we have to think, how can we actually measure this? And so often what we'll end up giving people is a number of items, so a number of questions that they can rate on a scale. And those items can be something like, I tell my partner often that she is the best. Or I tell my partner often that he, she they are beautiful, or attractive, or funny. And then the person would just rate it from, in this example, from 1 to 7. This is, again, another measured variable. We're not having them express gratitude to a romantic partner. You'll find in psychology a lot of variables are like this one, that it's hard to just have them circle, I own a car or I do not own a car. Usually you are going to measure different aspects of the conceptual variable with different items and have them rated or answer those, and then together those items create this one conceptual variable. Another one, this one is the manipulated example on the slide. So type of story told about a scientist. So in this one, researchers assign participants to read stories either about or about Einstein and Curie, which related either their work struggles or their achievements. So they read stories about these two, and they are randomly assigned to either the story focusing on the struggles or the achievements of the individuals. So this one, again, has 2 levels. It's a story about a scientist's struggles or a scientist about, or a story about a scientist's achievements. So we make that happen. We decide which one they get, and so it's manipulated. The last one, what time children eat dinner. Again, that's a measured one. So hopefully you're getting the idea. If it's something that just happens, we're not causing it to happen necessarily. It's just what ends up happening. That's a measured one. If it's one we assign, either randomly or not, that's manipulated. So in the book, it talks about operationalizing school achievement. You may not have given this a whole lot of thought before, but understanding what school achievement is can actually be very complex. So the conceptual variable itself is just school achievement. How are students doing in school? But you can operationalize this in a number of ways. One would be, what grades do they get? And that could just be a self-report questionnaire. So you just ask them, what grades are you getting? You could actually go in and check records. You could see what grades they actually get. So those are 2 different types. Even though they're both looking at their grades, they're 2 different ways of looking at grades. This last example is a teacher's observation. So you could actually ask the teacher how they're doing. A lot of science will actually use all 3. If it's a really important variable, they'll use all 3 to try to understand really what the school achievement is, because not one of those will perfectly tell us. For example, with self-report, often we might not know our grades super well, or we may feel like we don't want to say that we're getting mostly B's and C's, so maybe I'll just say, well, I'm getting mostly B's, even though I know that's not totally true. And when it comes to things like checking records, there can be a number of things. The difficulty of the class, the style of instruction that could affect the grade that isn't so much about school achievement. So each of those will have elements of school achievement and some noise incorporated in them. So with that in mind about variables, the 3 claims the book talks about are the frequency claims, association claims, and causal claims. Frequency claims are just a single variable measured and essentially counted. So 4 in 10 teens admit to texting while driving. So that is a frequency claim. There's 4 in 10. 42% of Europeans never exercise. Association claims are going to be 2 variables or more connected to each other. So an example of an association claim would be single people eat fewer vegetables. So it's saying being single compared to other ways of being in a relationship. Compared to those, single people eat fewer vegetables. Another one, angry Twitter communities linked to heart deaths. So if you are part of an angry Twitter community, which isn't too hard to find on Twitter, that is somehow tied to heart disease and death. The last one is a causal claim. So the association claim doesn't mean that being on Twitter in an angry community is causing your death, or being single causes you to eat fewer vegetables. It could, but that is not what the claim is. Causal claims are where one causes a change in the other. It doesn't mean it's the only thing that causes that thing, but it means it is a cause of it. So music lessons enhance IQ. So music doesn't totally cause IQ. IQ happens with or without music, but it could, according to this claim, it impacts IQ. Another one, babysitting may prime brain for parenting. So this one is a light causal claim where it says may, but still is a causal claim where it's saying it's babysitting is what's causing the change in the brain. Now it's important to note that these claims are used all the time in society, and they're not always based on research. So we talked about frequency claim. One way to pick this out is it's only one measured variable. It's not a manipulated variable, it's just a measured one. It's just how often does this happen? The association claim, again, it's two variables, and they're two measured ones. We're not manipulating either of them. So the synonym for this is usually correlate, so they're associated or correlated. This is just when as one increases, the other one tends to increase, or as one increases, the other one tends to decrease. So an example, here we have amount of expressed gratitude and relationship longevity, so how long the relationship lasts. If you look at this figure, it looks like as in general, as you go up in amount of expressed gratitude, you also tend to go up in relationship longevity. So the relationship kind of has this upward trend. So that's a positive association. Over here, frequency of multitasking and skill of multitasking. So as you multitask more often, your skill at it actually decreases. So as you're multitasking a lot, you're actually letting things fall through the crack more. So this is a negative association because as this increases, this one decreases. Now, zero association is where as one increases, the other one doesn't go in a direction at all. So time of dinner and childhood weight, that's really just flat. There's no direction. That's not this or this. Okay, so one of the reasons why associations are important is because we can use them to make predictions. So even if one thing doesn't cause another, it can be an indicator that something bad might happen or something good might happen. So it still can be useful for prediction. So the stronger the association between the two variables, the more accurate the prediction will be. So if we go back to these ones, the amount of expressed gratitude, let's say it was 10 for me. So it looks like somewhere between 1 and 4, maybe up to 6-ish, somewhere in here is where the prediction could be. So this isn't a very tight association. It is one. There's definitely a direction to it, but there's a lot of noise around it. There's not a solid, really tight line. This one's a little bit better, but still there's some noise. So the tighter that association, the better the prediction can be. So some verbs for association and causal claims. So when you're reading the literature, there's going to be a lot of association claims. Things like is linked to, is a higher risk for, is correlated with, associated with. Those are association claims. Causal claims, cause obviously. That's a good one if they say that. Affects, exacerbates, changes, hurts, adds. These types of words, be looking for those. And understand what side of the line they're falling on. Is it an association claim where they're saying these look like they go together? Or is it a causal claim where it says one is causing the other? So with these claims in mind, we have some tools to be able to deconstruct them a little bit. So the four big validities, these are generally the ways that we'll look at research and decide, does a study look valid? Does it look like it's actually telling us what it's saying it's telling us? So the first one is construct validity. So that's how well variables in a study are measured or manipulated. So this is really based on, do they measure the variables well, and are the variables actually what they should be measuring? So this is a lot to do with the operational definition. So does their measure actually get at what they claim is what they're measuring? Second one, external validity. This is the extent to which the results of a study generalize to some larger population. So if we're doing a study, this is how much we believe the results will generalize to other people. So an example, whether the results based on this type of music apply to other types of music. That would be external validity. So we try a study, we find music helps people relax. Maybe it's just that type of music, or maybe it's other types of music. Maybe it's just music in general. That would be a question of external validity. Statistical validity, this one is going to be tougher for you at this point unless you've taken a lot of stats courses. In general, statistical validity is just how well the statistical analyses and the data support the conclusions. Did they do the right statistics to answer their question? And are they interpreting the statistics correctly? Internal validity is really looking at the inside of the study, especially in experiments. So in a relationship between one variable, A, and another, B, the extent to which A, rather than some other variable, what we'll call C, is responsible for changes in B. So that was a confusing way to describe this, but it's essentially, does this variable actually cause the changes in B, or is it something else? Is it something else that we didn't adequately control for? So we'll talk about these. So when it comes to frequency claims, construct validity is going to show up a lot, because if they don't operationalize the variable correctly, then the frequency is just garbage. It's not what they're claiming. Often, what's really important for frequency claims is also external validity. How well is this generalized to other things? So if we do a sample of USU students and we find out 50% have struggled with depression, we're going to wonder, does that apply to all USU students? Does that apply to all students in college? Those are going to be really important questions. And then statistical validity. Did they actually do the counts right? Did they analyze the data correctly? So in frequency claims, these are generally the most important. With association claims, again, we have construct validity. So similarly for the frequency claim, except now you have two variables that need to be operationalized appropriately, or more, so two or more. So it's just going to take more work to interrogate the study when there's association claims. you'll have to say, well, did they measure depression well? Did they measure music, the context of the music well? With external validity, this still is the same idea. Does this association claim actually generalize to other populations, contexts, times, places? So if music helped individuals relax, does that only happen during the day? Does it happen at night? Does it happen to just college students because that's who we studied, or does it happen to everybody? Statistical validity in terms of association claims is when it's essentially the extent to which the statistical conclusions are accurate and reasonable, which here is saying, did they measure the association correctly? Do they interpret it right? Is the association really strong? Is it weak? And do they say that? So along those lines, two things to look for with statistical validity. We're not going to go into a lot of depth here because we're not required to have taken statistics before this class. But the idea is, do they talk about the strength of the relationship and the significance of it? They should be talking about both. Significance is whether they claim that the effect actually exists, and strength is how strong the relationship is, usually in terms of an effect size. There's two types of errors that you'll learn about in statistics more, but there's always a way, if you're making a conclusion that yes, an effect exists, you could always be wrong. And that's a type 1 error. Or if you make the conclusion that there is not an effect, there is no relationship here, that could always be wrong too, and that is a type 2 error. Research really tries to limit those, and when statistics are done appropriately, those can be minimized. So last one, causal claims. So the book provides this table, the 3 criteria for establishing causation between variable A and variable B. I think this is a good framework to work from. First one is covariance. So that is just, do they go together? So when A is higher, does B change? Does it go higher or lower? So covariance, it's a weird word, but it just means, do they go together? When one changes, does the other one change? They can change in opposite directions, but do they change together? Temporal precedence. This one is one that's easy to overlook. But this should be where A needs to come first in time before B. So if we're looking at relaxation and music, they should be presented with the music first before we measure relaxation. If we measure relaxation first and then we present with music and we're like, oh, it relaxed them, then it can't be that the music was what relaxed them. It could be something tied to it, that they knew they were going to listen to music or something like that, but it couldn't be the music itself. The last thing that's usually really important in causal claims is internal validity. We haven't really talked about this one much. It's not generally as important when it comes to the other 2 claims, but here we want to make sure that there are no plausible alternative explanations for the relationship we're seeing. Is B changing because of something else? We want to make sure that A, the variable that we are assessing, the manipulated variable, it's the only thing that changed during that time point. When other things do change, that leaves us open to, well, there could be something else. So for example, in education settings, this can come up quite a bit where we have a treatment. We have students, we present them with a treatment, and we measure some outcome. The issue with this can be that there can be a number of things that are happening to the student that could impact the changes in B. Our way of mitigating this issue is if we randomize to the groups. When we randomize, what that helps us with is it makes it so all of these other factors that exist out there are equal in the groups. Randomization helps us get to that. It's not perfect, but it's the best way we know how. So if we do random assignment, that'll help. So the reason why I bring up random assignment is because it is one of the best ways to support a causal claim. So experiments are what we, in psychology, build on to establish causation. So an experiment is where we have people come in, we manipulate one variable, that'll be called the independent variable. By manipulating, we put them in a group. And if we randomly assign them to a group, that makes it so each group will roughly have the same amount of depression and anxiety, or the same amount of experience with music. So if we randomly assign them, that will make it less likely that there's a third or other variables that are causing the change in your dependent variable, the outcome. So what's difficult is causal claims can be mistaken. There's always a chance that we're wrong. So, for example, do family meals really curb eating disorders? So in this one, if we're looking at covariance, so yes, there's an association between family meals and eating disorders. So that one we check. Temporal precedence, did the family meals increase before the eating disorders decreased? That one's less clear in the studies that we looked at. Internal validity, no. We can't rule out a third variable without an experiment. So in this case, can we assign easily how many family meals families are eating together? Possibly, but that can also be very difficult to enforce from a researcher standpoint. If we could actually start to understand the causal relationship there. Another one, does social media pressure cause teen anxiety? This one's an interesting one. So this one, the media really took as it's causing teen anxiety. The study itself was more correlational. So is there covariance? Do they go together? Yes, they're related. Social media and teen anxiety. The issue here is twofold. Temporal precedence, it was a correlational study, so they were both measured at the same time. Are you anxious? Do you use social media a lot? So no, we don't know. And then internal validity, can we make a claim that there's not something else that is causing this relationship? Could there be another variable? Yeah, and it could go the other way, right? So we could have teen anxiety causing more social media use. And maybe their anxiety puts them into high pressure social media situations. So the other validities, of course, still are relevant to causal claims. So construct validity, it really doesn't matter what claim you're looking at. If the measures aren't valid, then it doesn't matter what they're claiming. It's just not accurate. So you need to consider construct validity of both the manipulated variable and the measured variable, the outcome. So in this case, the manipulated variable, we'd want to know, were the groups, did they maintain what we thought they did? Was the music listening group, were they the only ones that heard the music? Did the control group also hear the music? Because that can be a problem. That's a problem with construct validity if they did. You can see that this can be very difficult in many settings that are more applied, where it may be easy for a control individual to get some of the treatment. External validity, this is not always really important with the causal claim right away. But often it is something that we are interested in. Will this generalize to other individuals, to other settings? A relationship to keep in mind is internal validity increases, external validity decreases, and vice versa. And then statistical validity, again, it's not going to be a focus in this class, but the same things that we've talked about with association, where we're looking at strength and significance, those things we'll still want to look at here. So, prioritizing validities. Which of the four is most important? So, this is one of those it depends questions, and that can be annoying, but it's just the fact of the matter. It's impossible for a study to satisfy all of the validities all at once. You can definitely have really good construct validity and internal validity. That means your external validity isn't going to be as good. And maybe your statistical validity might not be great, or it could be. You're just not going to find a study that does all of them perfectly. It's just not possible. But you want to look for studies that do them as well as possible. So when it comes to prioritizing in your mind, which one is most important, it usually depends on the type of claim. So internal validity is typically very important when it's causal, but when it's frequency or association, it's not so much. External validity is often very important with frequency and association claims. So keep that in mind as you're reading the literature, that you look at what claim are they making, and then really interrogate that claim using these validities and decide, does this look like strong research, good research, or does this look really weak and their claims are not very well supported? As you go into the literature review, I'm going to talk more about the assignment in the next lecture. But keep this in mind throughout as you're reading them. This will help you understand the research better, and you'll be able to make claims about the research because you'll understand what claim are they making. Am I convinced by this claim? And so that's chapter 3. Watch out for the next lecture, which will be about the literature review assignment. I've talked about how to find literature. Now we're going to talk about what the assignment will look like, how to write it up.